In conjunction with using the addition property of equality, we will often need to use what we call the multiplication property of equality. If we again think of an equation as a scale that is balanced, the multiplication property of equality allows us to multiply how much we have on each side of the scale, as long as we do it to both sides. For example, if this scale is in balance with 2 blue triangles and 2 red squares on the left side, and 4 green circles on the right side, I know that if I triple how much is on both sides, essentially multiplying the value on both sides by 3, it should still be balanced. Now each side has 3 times the quantity it had before, but because they were balanced when they had the initial quantity, having 3 times as much still means it will be in balance. Similarly, while we can triple up how much is on each side, we can also cut down in half what is on each side. If I were to have half as much, essentially divide the quantity on each side by 2, and I were to remove that from each side of the scale would still be in balance. This is the multiplication property. Algebraically, we describe this as the following. If we have some equation, a equals b, then we can multiply both sides of the equation by any value c, so long as we do it to both sides, and so long as c does not equal 0. Multiplying both sides of an equation by 0 negates all information contained on either side of the equation. Also keeping in mind that division is a form of multiplication, the multiplication property of equality allows us to divide both sides of an equation by anything we want, again so long as we are not dividing both sides of the equation by 0. When we put the addition property and the multiplication property of equality together, we are able to solve any linear equation.